Hi, I'm Mike. I am a hoarder. Anyways, so we have yet another Powerbook 100. Oh, this is crazy. So what ended up happening was I got two of these in for repair by someone else, which I can't remember. I think I released one of those videos, but not the other one. So I got two of these in for repair. And I thought I had the best of both worlds because what I enjoy doing with this is I enjoy tinkering with it, I enjoy repair it, and then I enjoy playing with it a little bit, and then that's it. So I'm like, you know what? It's the best of all worlds here because then I get a laptop. I don't own it, so it doesn't occupy space or take my time. I tinker with it, I play with it, I get it fixed, and I kick it on down the road back to its original owner. It's all hunky dory, right? I get my fix, and then the machine's not taking up space or becoming a shelf queen because that's the other problem. Well, after I do my tinkering and playing around with it, the waters get a lot more muddy and murkier because they kind of become shelf queens and I don't really mess with it again. That's not a good thing. Anyway, so but it's like I get my fix, but there's that little bug gnawing in the back of my mind. I'm like, I kind of want one of those. No, Mike, you don't need one because it's just a reduced down Macintosh portable, and I already got three of those. I don't need. Guess what? A deal popped up that I couldn't refuse where I got a pair of them, which I don't think I've released the video on yet. I got a pair of them, and now I own two of them. And then, in the middle of restoring the Macintosh portable for someone else, this one popped up with an intact screen, and it was a deal that was too good to refuse. And so now I have a third one. So that's now five PowerBook 100s I'm going to be working on. Anyways, so yes, I am a hoarder. But anyways, the goal here is, this is the goal, is out of those three I now own, I'm keeping one. And then I got like a spare logic board, I think, and I have one of the old screens from the first ones I fixed that has a stripe in it, but the polarizing film and all that's still gone. So I saved it. I can keep that as a spare. And I'm selling the other two. I bought this one with the sole intention to resell it after I fix it. So I get my fix again, but then I can pass it on to someone else who just wants to have it, to play with it, to use it, and not necessarily repair it. That's the intention, anyways. Moving right along, since I don't think I released the other two videos yet, I'm probably just going to lump this into the same video. So this will be a third one that we've worked on. Now, I've noticed that these feet are like one was missing, and this one they're kind of loose, but they're there. And I noticed the color difference. Like this laptop is extremely yellowed, but this one is not. However, I think this is a different plastic because this one gets brittle, but this one doesn't. Plastic chemistry just kind of, and aging just kind of fascinate me. So, moving right along, we have, your traditional ports on the back like they all got, but this one's missing the door. There's some crud over here. The bottom, yeah, we got melted feet. They all have to be cleaned off. This one's same deal. It's melted. It's just, yeah. Don't know if it has any funky upgrades or anything like that in there. We're going to find out. But if the rubber feet are melted, I guarantee the LCD panel is also melted. Still has its original battery. Yeah, there it goes. Oh, yeah. You can see the rubber sticking to the palm rest there. So that rubber is going to have to come off of the machine. But otherwise, there's no sign of vinegar syndrome. I don't smell it. And there's no impression damage from the trackball, because that is a very, very common problem on these. But I honestly think that these screens go bad for other reasons too, but I don't see any damage. You can kind of get an angle on it where the light hits it a certain way and you would see the impression in the screen. So we're good there. We do not have any bad LCD, and that is the one reason why I picked it up, and it was a good price. Let's check the battery. Ooh, the battery's still intact. Is there any corrosion? No, there's not. It's kind of interesting. I think this was left in like a UV environment because this is still nice and gray, but you go to the front here, it's yellowed. Yeah, it was definitely exposed. Yep, that battery's junk. Now, the other problem is, even if I wanted to put a replacement battery in here, I don't know how you would rebuild this one. Because this is the whole thing is the battery. This whole thing is the battery. You can't just pop it apart. You can cut it apart, and then the only thing we can do with this is try to create a 3D printed replica and hide. It's so thin you can't put like 18650s or anything in here. So you'd have to use those flat lithium polymer packs and then use a BMS to handle that. The meter will not work properly, but it'll work if you wanted to run this on battery anyways. Moving right along, we'll set that aside. We got all this nasty rubber crap that's got to come off of here. See how bad this trackball is. The clickers work. There's a little bit of key wear, but nothing hasn't been overly used. Oh man, nasty. Nothing super serious. I mean, the keyboard's a little dirty, but not terrible. It's all intact plastics. The feet are at least there. Yeah, we're good. So I think at this point, we should take this thing apart or start taking it apart. So I got to get this trackball out. I don't know how. Yeah. Anyways. Oh, I also got some footage from the first two Powerbooks that I restored. I think one of them I did put on YouTube already, but the other one I didn't. And the reason why is because I used to have a camera up here that wasn't a very good one, and it took horrible video. So I've got to just do away with it. And I didn't upload that footage, but oh man, that sucks. That sucks. That's all melted too. That's got to come out. Yeah. It'd be nice to have replacement rubber bumpers in there. But alas, we do not. Yeah, look at this. See the rings? So yes, this is strange because it's even yellowed through here. So it's almost like this thing was left open like this and just saw tons of fluorescent lighting. Like hours and hours, days, years of fluorescent lighting. It's kind of strange. It's even yellowed on the bottom a bit too. Not as much, but it's definitely there. I wonder what environment this thing was used in. The keyboard feels good on these. Unlike the Powerbook Duo. Those are horrible. Alright, that's enough fucking around. Let's get this thing apart. Just slip the keyboard off, and yeah, this thing is really bad. Like, look down in here. You can see all the corrosion and goo just sitting in those vias. Same thing over here. And then it gets really bad through here. Look how much it ate that transistor away. And here, let's see it again on the keyboard. I don't know if that's cap juice or something got spilled in there. That's a very interesting observation, because I mean, don't get me wrong, this stuff gets really nasty anyways, but let's see, let's take a look at the CPU. Yeah, I mean, ooh, God, that's bad. I almost feel like something spilled in here, but it could very well just be capped crap. Looks like we've just got a traditional small RAM board here. I don't know what the amount of RAM it is, because there's some on board. I think there's like 1 megabyte on board. I think there's only 1 meg here too. Yeah, it's not coming out. I'm just gonna leave that for now. Okay, is the hard drive still in here? Yep, it is. Whether it's any good or not is yet to be determined, but it's still in there. Oh, so disgusting. Actually, that's flux. That's hard. Let's see, what's this stuff? Is this, no, that might be flux. That's not. That's, oh yeah, it smells like fish. Yeah, we definitely gotta wash this board. Alright, I can't get this out. I tried my hardest, so I'm gonna have to go from the backside. Actually, this thing still has its original Connor hard drive, and it's the 40 megabyte instead of the 20 megabyte. So this was a later release Powerbook 100. Got the board extracted, and one thing I noticed right away, the back side of the board generally looks good. I don't see any corrosion starting on the back side where juice has leaked through, but I did notice this. Look at that. Well, that's no good. I can't imagine that was working too well. I bet when this machine was last being used, they were suffering with that quite a bit. I actually decided to start cleaning the rubber gasket because that stuff was just getting everywhere, and it's nasty. So I was gonna do this first, but this, yeah, what a gooey mess. This side here was harder to get off than that side, because that side it peeled off relatively easy. This side, no. Had to use a combination of this this stuff here, adhesive remover, and alcohol to clean, Q-tips and pick tool to try to get all that out of there. That was gross. Problem is, I don't have anything to put in its place. You could get rubber TPU filament type stuff. The problem is this has got an arch to it. And the one thing about 3D printing and CAD design is I don't know how to do this arch thing. It's beyond my skill set. So it's just going to have to ride like that until something's figured out. Unfortunately, also, the standoff is broken. If you look very carefully, it's cracked. So we've got to fix that. It's just like all the other Powerbooks where the plastic shrinks around the standoff, and because the standoff can't shrink, the brass nutsert can't shrink with the plastic, it cracks the plastic. So the way I fix these, this one is wonderfully is not too bad. So the way I fix these is I just soak these in the Plastistruct MEK stuff to soften up the plastic to try to bond it back together, but I also heat up the nutsert and clamp it just to kind of squeeze it back together again, because the plastic is shrinking anyways, so I might as well resize it to get it back down to where it needs to be. Something kind of like that. Now, it's not perfect, and it's probably not, I don't know how long it's going to last long term, but you can kind of see where the cracks filled in with the MEK, and it sealed itself up, especially when I heated it with the soldering iron and grabbed my pair of these thingies, I keep forgetting what the heck they're called, to squeeze this guy together. So that should work. This is what has all the load on it. I also heated this up a little bit. It's hard to get in there because my soldering iron tip's not big enough, but I need to heat these up and kind of do the same thing, let the plastic relax around it, shrink a little more, so I can hold the torsional forces. Because from what I can tell, 3D printed versions of these standoffs for the Powerbook 100 don't exist. They do for the 140 and newer, but not for these. And you can't like wrap epoxy around this side because this is the part where the cable snakes through. You have to leave this open. So we need to have a standoff 3D print block right here. But remember, these two standoffs are at different heights. So when you design a new 3D printed insert, you got to pay attention to that. Same thing on this side as well. So now we're going to move on to washing this board. I got all the old caps off, had to grind down this little ground pad here. So we're going to go wash this up, clean it up, get all the cap juice off of it, and repopulate it. But before we do, I've run into another problem. So these MOSFETs that I removed here, there's some corrosion on the pins of these. So what I ended up doing was test these MOSFETs with the multimeter, and they're bad. The gate channel has so much leakage that they won't hold a charge to turn the channel on anymore, whereas this one works just fine. So we're going to have to find some new P-channel MOSFETs from somewhere. I don't know where yet. I might have something in a parts board somewhere. I don't know. We'll figure that out. But yeah, that we're going to have to find some replacements for those, but that one's okay. All of the caps have been replaced on the LCD panel. Now, in between taking them off and putting them back on, I washed this board to try to get all the goo up as much as I can. I use these microfiber cloths to try to protect the film from getting damaged, from like solder splatters, flux splatters, things like that, because it's not like we can replace that film. This is a passive matrix display, and the problem with passive matrix displays is you need the retarder layer in order to get the right color purity. Otherwise it would be kind of a purplish or orange and it won't look right. So doing everything we can to protect this film, which actually brings me on a tangent. Every single one of these displays will go vinegar syndrome eventually. What I'm curious about is if it's possible to use heat or whatnot and save this film without damaging it, cleaning off the adhesive and then reapplying it with fresh adhesive to try to prolong the life. But I'm not sure on that without damaging it, because you don't want to get ripples in the film, and you don't want to, destroy. And even the film is not really that bad. It's the retarder layer that sits underneath the film that's bonded to the glass that I care the most about. because that's the part you can't really replace. Alright, so all of the capacitors are in there except for the two in the middle. I can't put those in until I put those two MOSFETs in. The problem is, I do not have any more of those insulated gate or insulated tab MOSFETs. I do, however, have a parts Macintosh portable board, which essentially is the same thing. I'm just going to steal those two MOSFETs down there and reuse it. Now, because the tab is not insulated on those, I've got to make sure to insulate those myself, and I'll probably just use Kapton tape to do that, just because it would be easier. Just wrap around the transistor and protect the board, and then that heatsink clip goes over it anyways. new caps are in. I got the new transistors in here, which are, they're not pretty, but they'll work. Because I seriously doubt I can buy these new. I'd have to get something equivalent to that. But that's in there now. The only thing I got to do now is I'm just going to go ahead and put this together in a primitive way to make sure it all works before I start buttoning everything up, because I don't want to put everything together just to find out that we've got a serious problem with this board, because I did see some via rot down here. So I am somewhat concerned that we're going to be missing voltages, but I won't know until I get everything back together. So I'm going to get this together real quick in the bottom cover, and we're going to fire this thing up. Alright, so we're just kind of loosely in place here. We're going to try this thing out and see what happens. Ooh, yeah, we got a chime. Do we actually have an image? Let's find out. It looks like we do. Nice. Nice. The backlight's seen better days, but you know what? We actually have an image. Nice. I haven't tried the mouse. I got to plug it in, but wow, that works. No weird lines, no distortions, no screen cancer, no damage to the trackball spot, which is like normally right here. This thing's amazing. It's in good condition, which I like. Alright. It's a little bit dim. I think the CCFL bulb has seen better days, but it's doable. I like it. Alright, so we can continue moving on. Remember, we got to do the diode mods so we can put the Blue SCSI in here, and I already took care of the DC jack soldering because it was pretty bad. And then we got to work on the mouse because it needs the rollers all nice and cleaned out. But the recap worked fine. Kind of like that. Modded for Blue SCSI. Is it perfect? No. But it will be hidden on the bottom, so you're not going to be able to see it anyways. Can we get lucky squared? We're going to try the original hard drive. See if that works. I already cleaned the mouse ball. No. That is a no. And the mouse ball isn't working very well either. No. Not very good. I think it's just heavily worn out. Oh yeah, there's more dirt on there. I might have to replace these rollers. They're very sticky and not very good. Let's see. Yeah. Okay, so I see the problem. We're a little bit offset. No. Yeah, it's weird. It's like it's getting stuck on the... Anyways, hard drive's no good as expected, so we'll pull that thing out of there. Oh yeah, look at this. magnet delamination. So the magnet is delaminating, which is pushed up against this thing, which popped that off when it was jammed into the head. So the head can't move. But more importantly, not only could the head not move, the head is also, the rubber bumper is also stuck in that thing. So that's not going to move either. So we got to fix that too. I mean, I don't know why I would fix this drive anyways, other than maybe potential data recovery, but outside of that, this drive isn't going to be used anymore regardless. But that right there is just another indicator of why hard drives fail. This is probably the worst idea ever, but I cut off the delamination part and I'm gluing it back together. It's not going to last, but perhaps it'll last long enough to determine if the drive has any software that's worth saving or not. That's the whole point of this adventure. Another thing that was done too was the molten rubber and wax was removed out of here along with the magnet. I reinstalled the magnet around a piece of old rubber belt, so that should solve that problem. Hopefully the drive will last long enough to be able to back it up onto a Blue SCSI or something, and then we can get rid of it. It's going to take a good 12 to 24 hours for that stuff to cure. So in the meantime, time to get our ultimate solution in place, which is this Blue SCSI. Now, I peeled the shield off and just kind of shoved it up underneath here. That way, the Wi-Fi signal is not impeded by this aluminum shield that sits here, because the palm rest doesn't have any shielding whatsoever anyway, so that should solve that problem. Alright, yeah, let's get this thing back together. This doesn't have an operating system or anything on it, so this does have the Danaport emulation on number 6. In fact, actually, before I put this in here, I actually need to update the Blue SCSI because there's a new firmware out that fixes a lot of weird issues. So I'm going to go ahead and do that prior to doing this. We have it fully reassembled now. Got it cleaned up as best as I could. Keyboard still needs a bit of work, but I'm not worried about that right now. I got to take this back apart eventually anyways to do a retro bright, assuming I don't sell it in between, because this is one of the ones that I picked up to resell. But Blue SCSI is installed. We don't have any image on the, or any OS installed on the Blue SCSI's SD card yet, but the machine is on, it's running, it's kind of dark. That might brighten up once it actually loads the OS and loads the brightness extension, because the brightness control is not in ROM on these. It's part of the driver that's in the system software that recognizes the brightness control and all of that. But anyway, so we've got our machine up and going. We just have to get the Blue SCSI external in here and my floppy drive so I can install the system software. Alright, well, just when you thought you're done, you're not. So in the middle of installing the OS, this lower third just went black. And I hate it when that happens, because it's like every single one of these displays do that. I've already went through this hassle before. So I need to pop this bezel off and see what happened. So it's either a trace, because the caps sit here, so it's inevitable. So either a trace has gone open to this ribbon cable, or there's a break right here at the edge of the cable. And if there's a break in the edge of the cable, I'm not sure how I'm going to fix that. I think you can kind of grind through it and then patch it, but I've never tried that. So I don't know if I can do that, because I have another one of these panels that I had from working on another one that the same thing happened to. So I'm hoping it's the former and not the latter, but that sucks. That's what happens when cap juice sits on this stuff and just eats away at the copper. So the good news is there's absolutely zero damage to the cable. Thank goodness for that, because holy crap. So the cable is fine. Our problem is going to be a trace going to one of these pins is open, which makes sense because all the caps sit here and we still got some fuzz Even though I washed this board, there's, you know, there's some fuzz in there. So we're going to have to do some checks and see what's open, because a lot of these control lines are in parallel, but then there's a series in and out, I think. But the because I'm pretty sure the control signal starts here and snakes its way down from top to bottom. So a lot of these control signals are in parallel, but then there's going to be a serial in, out, in, out, in, out, and then over here. So there's probably a break between out and then in. But I'll check that for sure. All right, well, I did some checking with multimeter and they're all good. So I was able to use a magnifying glass and I got a little bit closer. And there it is. So the fifth and sixth pin in, you can see it broke pretty much right here. It's normally they break right where the exit point is, but in this case it didn't. It literally, you can see the dark spot right in the chip, right where those leads go in the chip. So unfortunately, that's it. So I don't know how I'm going to fix that. You know, if it was broke right here at the neck where I had more girth, I could grind that back and patch it. But it's broken literally right where it goes into the chip. So that is not good. Which is weird to me, because if the cap goose came in through this way, so it must have come through the ribbon on the other side. So I wonder, I kind of wonder how hard it's going to be to fix this, because I might, oh crap, because I could lift this cable and grind the plastic off from the other side and patch it, but I don't know. This might be EOL for this panel. That sucks. That really sucks, because these machines are expensive now. And I went through all of that work and it was working fine. And then that happened. And every single time. That's going to become a huge issue with those panels. The longer these sit with cap juice, the worse that's going to get. Well, what I ended up trying to do was, if you look carefully, I ground through the cable there and I buzzed it out, and it's still connected even though it looks bad. So the break is either under that chip itself or the chip is bad. But the circuitry between the ribbon's fine. I checked it, but look, it's definitely dead. So that's unfortunate. That's beyond repair. My only other hope would be, because I have another parts panel, would be able to figure out how to save the ribbon off the other one and transplant it. I don't know if that's possible. Maybe with a hot bar I could pull this off, but I don't know. Well, the good news is you can actually remove these cables with a hot bar. I just used my soldering iron and just slowly worked at it. But if I had an actual hot bar, you can pull these cables out and replace them, because this stuff is like an adhesive, I guess. It's just meant to, anyways. So here's what happens. Now, when I pulled this chip out, the chip is actually molded and is part of the cable. So the capacitor juice, you can see how bad it is. The capacitor juice just kind of wicks up inside the cable right from there. And it's damaged the chip. So what I did was I checked the voltage. I had like 26 millivolts here, but 0 out here. So the chip was not getting power or functioning whatsoever. But I got 26 millivolts here, here, and here. So these three are functioning. My only opportunity would be to try to properly salvage a cable from the other panel and move it to this one. I don't know if it's going to work, because this is fiddly and this takes specialized equipment to do. And what makes it suck is there's a piece of tape here holding it down, so you kind of have to work at it. Well, when you do, it kind of like mangles those, and it's just I'm using this low temperature alloy to try to remove it. All right, so now we're about to try the impossible, basically. I have another LCD panel that has the exact same problem. Now, this is the panel from the very first PowerBook 100 I worked on, which has the same problem, the bad ribbon over here. Now, it has 3 good ribbons, 1 bad ribbon, just like this one. 3 good ribbons, 1 bad ribbon. And the chip itself, the 100-bit shift register, just died. Who knows? So that's bad. I want to remove the bad ribbon off of this one too. I'm going to practice a little bit more because this one kind of got mangled down here. So I got to be careful with that. I was able to remove this part without any trouble. It's the part at the bottom that's not very good. Also, I got to make sure not to touch this with my finger oils on the other one. Anyway, so this one's garbage. I'm just going to try to do that first, succeed at that, then remove a good ribbon and try to move it over here. Now, I'd like to get another one of these panels that has either vinegar or cracked screen or whatever, and just steal the 3 good ribbons off of it and try to repair this panel too, because both panels have the exact fault. So, yeah, I have my chance of success here is probably about 5% because there's 2 big hurdles. Besides removing the cable, say I remove the cable successfully. Hurdle number 1 is getting it lined up precisely right. There's a square here and a square here, and there's a marking on the cable itself. We have to get it lined up perfectly perfect. And then we got a hot bar, which I don't have a hot bar, so I'm just going to use like this knife tip right there and bond it back down. So that's the biggest hurdle. Once I have it bonded down, then I can solder it down back here, and hopefully it works. But I have a suspicion what's going to happen is I'm going to have lines in here where it's not really bonded well or something like that. So these little, I don't know, bonding glue tab things are really meant for one-time use. So I don't know how well that's going to work, but we are going to try. There's actually on eBay, they sell a tool. It's a T-bar soldering iron, and it's just a big wide bar with a silicone tube type thing on the front of it that sits in between here and the actual tool. It's designed for doing this type of work. The silicone I think the silicone protects this cable from getting damaged from the exposure of the direct heat on the iron. But yeah, you need that hot bar, and you got to keep pressure on it, because what it does is it melts this glue and it fuses the glue between the cable and the glass. You can see how it was done right here. So it's a special tool for that. I don't have it, so that, like I said, the chance of success here is like 5%. But you never know. And honestly, I'm not out anything because both displays are junk now, technically, and both displays have the same problem. So what's there to lose besides a little bit of time? Yeah. Well, is it doable? Yes, but like I said, about a 5% chance of success. You got to have the right tools for this. So it kind of works, but not really. Anyways, moving right along. It's been about a day later, and the magnet assembly is all glued back together. So hopefully that will last at least a little while anyways, because I'm curious if I can recover the data from this drive. This is only for data recovery purposes and not for actual use, because now that it's been exposed to atmosphere like this and we got all this craziness happening, it is not going to last very long. But it will last long enough, assuming it will initialize, to recover any potential lost software on the device. So we'll do that now. Until then, we're kind of stuck waiting on that 3M Z-axis tape to come in. Hopefully it works, because that tape says it has a minimum 0.4 millimeter pitch. but it has 0.1 millimeter grain. But this is a 0.2 millimeter pitch cable, so this is our final hope. If that doesn't work, there's no repairing it, but we'll give it a shot. I know the Blue SCSI can do initiator mode, but I don't have the proper cables for doing initiator mode for these kind of drives. So instead, I have this old Pocket Pro 25S external SCSI enclosure that fits these 2.5 inch hard drives. So we're going to use this with a modern, well, not really modern, but like a Blue SCSI plugged into this plugged into the back of like a compact Mac, and we're going to use this guy to back up the machine. So with the Blue SCSI, with this thing and a boot disk, we can transfer the files between here and the Blue SCSI with a blank image, and then call it a day. So that's what we're going to do with this before this drive ups and dies. And there may not even be anything on this drive that's worth salvaging. There just may not be, but I can't determine that until I know for sure. I do not have a power adapter for this hard drive caddy, so I have to feed in the external power. And remember, this thing is center negative. I had to take this apart and double check, because the termination power is not going to be enough to spin up this big hard drive. So here we go. That's certainly better. It spun up. Ah, you stupid Blue SCSI. Alright, well, that was unfortunate. So the reason why this was blinking is the SD card decided to short out, and it was burning hot. It actually burnt my finger. I thought I blew the whole Blue SCSI up. No. But that doesn't make sense, because the configuration here shouldn't be illegal. So perhaps it was just a spontaneous failure. So the thing is, these hard drives require external power or they won't spin. There's not enough power on the termination bus to really run these drives. Alright, so let's try this again. So this time I'm going to power it up by this and then energize it. Well, yeah, now we're booting. Whew, wow, yeah. Spontaneous SD card failure. Really? That's what it was. Well, it seized the drive. Oh boy. What would be hilarious is if this drive was formatted and I did all this for nothing. Anyways. Alright, here we go. Back it up first. Tinker with it later. See, that's the downside of data recovery, because using period era hardware to do the job takes longer to perform the copy than the hard drive has left of life, because it just died right there. Upon first glance, I don't really see anything that isn't already archived, but the drive is definitely bad, if we didn't know that already. It's getting worse the more I try to use it, because the surface media surface is starting to degrade little by little. Yeah, I'm running Norton Disk Doctor, and sure enough, it gets to about a third of the way in and it finds bad sectors. So yeah, and the problem with this drive is it just hangs and hangs and hangs and hangs, and it makes it hard to do this. So anyways, I don't see any software on here that's really worth saving, and some of the stuff I already did save, so all the personal documents, schoolwork, stuff like that, I don't care about, so I'm not saving any of that. So we can go ahead and kick this drive down the road. Not important, but I just wanted to see if I could recover it enough, spin it up enough to see what was on it and if there's anything worth saving. And we've achieved that task. So the more important thing now is to wait for the Z-axis tape to come in so I can see if I can fix the LCD display. All right, well, I got as much off of that hard drive back here as I could. It was freezing when it would try to do the sector scan, so I just gave up on it, powered everything down, and powered it back up, and I blew another SD card. So when I say blow, it just, as soon as you power the SD card up, it consumes a ton of current and gets extremely hot and starts smoking. That's the second one. Now, in between the power down and power up cycles, I copied the image off of that thing, then I fired it back up, and that's when it all went south. Here's what you have to do, or at least to replicate the problem. First, I turn the power on, everything energizes, hard drive tries to spin, but it can't spin all the way up. So I kick this power on, and then everything spins up, but it blows the SD card. So I'm wondering, and even then, I didn't even get a chance to energize this up yet the first time around, and it burnt the SD card. So I'm starting to wonder if the back EMF or spikes or something's coming off this hard drive when it spins the motor up, and it's getting back into the Blue SCSI and killing it. I don't know. But it only affects the SD card. It's not killing the rest of it. Probably because there's a regulator on the rest of it, where the SD card, I think, is connected directly to 5-volt power. Maybe we need a transient voltage suppressor installed on the VCC line to prevent that from happening. Although this setup is unusual. Nobody's going to have a setup like this. It doesn't make sense. So that, just one of those oddball planetorial alignment scenarios where this setup is going to blow up the SD card. I might have to put a 5.6 volt transient voltage suppressor or something in here to prevent that from happening. So I got to the bottom of what happened, but I still don't know why. The Pico has been damaged. So it blew up a second SD card, like I said. And things seems to be working, but what I noticed is this little chip here, which is a 3.3 volt regulator, which has a maximum input voltage tolerance of 6 volts. So my guess is when that Connor hard drive would spin up its spindle, it would produce like a back EMF or a kickback voltage spike or something. It blew out the regulator, which blew out the SD card. And how I figured that out was when I had this thing powered up on the bench, this 3.3 volt regulator was putting out 4.7 volts. And somehow it was still working like that. But I noticed the Pico was getting very hot, and that isn't quite normal for these. But it was still working. Now, that voltage regulator could be replaced. I don't know how easy it is to do that. And to buy another Pico W was like $6. So it's, by the time I bought this chip and paid for shipping from like DigiKey or Mauser, it would be cheaper just to replace the whole Pico, which is what I'm going to do. So for $6 on Adafruit, I'm just going to replace that Pico. I need some Pico Ws anyways for some other desktop Blue SCSIs that I have that are non-Wi-Fi. So I bought a few of them, and we're just going to replace that. So fast forward a little bit of time and some more research. This stuff here, that little stripe, pinstripe, that is what's called an ACF, or an anisotropic conductive film. And it's the same stuff. It's a Z-axis tape, kind of like this stuff here. Difference is this doesn't have any actual adhesive on it. It's just a piece of ribbon. And there's a bonding machine that's designed to work with this ribbon. You load it on with like a reel and you lay it down. Preheats the ribbon to a specific temperature based on the profile of the ribbon, kind of like a 3D printer with TPU filament. And then it comes down, presses it, heats it to the temperature, gets the glass at the right temperature, and then the ribbon goes in there, and then you press the ribbon in. And it's a press. It's a heat press. It leaves it on for so long, and then that's it. You're done. Now, I don't have that equipment, so the next best thing is this stuff here, which is a 3M, let's see, this is a 3M 9703, which is basically the same stuff. It's an ACF film. Difference is it's a bit more coarse of a grain because it has an actual tape adhesive on it. So I'm hoping that this works, but it says the minimum conductor width to ensure full electrical isolation is 0.4 millimeters. We're working with 0.2, so I don't know. I don't have a whole lot of high hopes, but this is my last ditch effort without having a $2,000-3,000 bonding machine that lays out ACF ribbon and all of that, because that's the right way to do it. But if this works, I'm not going to complain. So we're going to try that. Yeah, pretty much about as far as I'm going to be able to go with this thing. There's not much I can do. I mean, once these ribbons go bad, that's it. It's unfortunate. I mean, I gave it the shot with this Z-axis tape. Unfortunately, the Z-axis tape does work. It's just I can't get enough pressure on that thing to actually do anything with it. It's just, I don't know. I really don't know what to do at this point. I'm kind of at the end here. It sucks because of all the work I just put into this machine just to have that. And I had someone who was interested in buying it too, but it's not happening now. That really, really sucks. I hate losing. In this case, I lost. I lost. It is what it is. That's the unfortunate game of Russian roulette. You got to play with these machines. So I've got one of these machines. Actually, no, I got two of these machines that work. I'm probably just going to sell them and get it out of my hair, because I know if it's not for that ribbon going to go bad, it's going to be vinegar syndrome. It's one of the two. So I'm done. I'm calling it. Anyways, it is what it is. A lot of these failure videos I don't upload, but this is kind of one of them. I think I will, just to kind of show everybody what it's like dealing with stuff like this. So anyways, if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.